Welcome to the Industrial IoT Spotlight, your number one spot for insight from industrial IoT thought leaders who are transforming businesses today. With your host, Eric Walenza.
Welcome back to the Industrial IoT Spotlight podcast. I'm your host, Eric Walenza, CEO of IoT One, the consultancy that helps companies create value from data to accelerate growth. And our guest today is Gabriel Rene, CEO of Versys. Versys is the company behind KOSM, the world's first network operating system for distributed intelligence. In this talk, we discuss the coming explosion of AI-based super tools built on the converging maturation of AI, IoT, robotics, and AR, of which ChatGPT is the most recent example. We also explored the challenges facing this technology development, ranging from the need to lay a strong rules-based foundation to build safe AI upon, to engagement with governments and integration with legacy business systems. If you find these conversations valuable, please leave us a comment and a 5-star review. And if you'd like to share your company's story or recommend a speaker, you can email us at team@iot1.com. Finally, if you have an IoT research, strategy, or training initiative that you'd like to discuss, please email me directly at erik.walenza@iot1.com. Thank you. Gabriel, thanks for joining us on the podcast today.
Great to be here, Eric. Appreciate the time.
So, Gabriel, this has got to be one of the most ambitious companies that we've had on the show recently. So I'm really looking forward to understanding your vision for how this space of artificial intelligence, general intelligence will develop. But before we go there, I'd love to understand a little bit more about your background and how you made the decision to throw yourself into this incredible challenge. So it looks like, you started all the way back in 1992 as a sound design engineer, so you have kind of an engineering background. And then you set up this World Internet Center, which is quite an interesting concept back in the boom days. What was the concept behind that?
Well, so in the early 90s, I started working in an advanced R&D lab called Cyber Lab, which was sort of tip of the spear, really aggressive emerging tech R&D group just out of Silicon Valley that some of the biggest companies, Microsoft, Apple, Intel, others would outsource some of their sort of impossible problems to government projects and other things. And so I was lucky enough to sort of join this cyberpunk crew of, everything from scientists to deep tech nerds to hackers and PhDs, and to have this opportunity to be exposed to early technologies. The founder of CyberLab, Dan Mapes, had a background in artificial intelligence. Dan's actually the co-founder of Versys today. So 30 years later, we still working together. So being exposed to that early 90s era of technology when the web was first emerging was really exciting. And I also got exposed to way more advanced technology, certainly like that sort of expert systems around artificial intelligence, but got a chance to work with like Dr. Tom Furness in the Air Force on early augmented and virtual reality headsets. And so experiential, immersive computing, way back in those early days. And that was the age of digital media. So the whole idea that you're playing with audio and video and computer graphics and real-time computer graphics, like silicon graphics machines and stuff with even performances around that. It was suddenly this moment where governments, large corporations, movie studios, like everybody wanted the same tech. And the irony was that the sci-fi stories of that time, the kind of cyberpunk stories, were talking about this world where you'd have these like hyper speed networks with AI agents and robots and flying cars and all the sort of sci-fi stuff of the era. And meanwhile, it'd take 5 minutes to download a stamp-sized JPEG on the web. And so this vision of this sort of hyper immersive sci-fi techie future, relative to the reality of how slow compute was, how slow the networks were, and the rest, was kind of an interesting, area for a young man like me to be thrown into. I was one of the younger guys in that field at the time. So that was really where it all started. What really shifted over the years was that the idea around the sort of immersive network of intelligent technology never went away. And I ended up working on lots of projects in different industries around the various pieces. And so then as mobile started to emerge, I got into the mobile industry in the early 2000s. This then led to Internet of Things and wearables and network optimization and kind of understanding the global network at scale. And as I got older, what became clear was that the ideas behind these sort of sci-fi stories with the really cool technology, that stories we all, sort of love, are fundamentally horror stories about horrible dystopic futures with the coolest tech that we want in worlds that we don't want to live in. And so ultimately this led to when I was in telecom space in the mid to 20 teens, the investments that were going into 5G that the telcos were making were all the result of research that essentially said that the main users of the network would not be human. It would be machine to machine. It would be autonomous cars and drones and vehicles. It will be holographic, augmented reality content. It'll be in industrial Internet of Things and manufacturing robotics. And so the largest infrastructure investment in history that every telco in the world did at the same time into 5G was based on the idea that we already had 120% human penetration with everyone had a phone and a half or so, and that the future was about this convergence of these technologies. When I saw that was happening, I saw Oculus get purchased. We saw the breakthroughs in deep learning that started to come out of AI, that the Internet of Things and sensing systems were starting to sort of move. I called up my old boss from CyberLab and said, "Hey, are you seeing what I'm seeing?" And he said, "Yeah, it's like this convergence of all these things are reaching a certain maturity point. 25 years, we've been talking about this stuff for 25 years. Let's get in the middle there and see what we can make." And so that was what spawned Versus, was the idea that the convergence was coming. We've been watching these trends, working in and around the edges of all these technologies in some of the most advanced areas of them for decades. And then finally, wow, the great convergence is coming. What kind of shift is that going to create? And if it's about the power of exponential technology now becoming part of this sort of network of exponential technology, how do we angle that to make a better, smarter world, and with cool tech, and not just cool tech with a horrible dystopic world? And so that was really the motivation.
Yeah, no, that's a good outlook on science fiction, and I think that to some extent the general perception for how this might roll out, or at least the general perception among kind of the more sci-fi part of the population. I think it was Lex Fridman who hosted Neil Stephenson on his podcast a few weeks ago, and they were discussing this. Basically, this is kind of a unique. It's a unique problem area in that you have to solve the problem before it emerges, right? Because if you're dealing with like the chemical industry, you can kind of wait until pollution gets out of control, and then you can say, okay, this is a problem. We've got to rein it in. Let's get the regulators involved, and we can control the chemical industry. With general AI, you can't do that, right? You can't wait till the general AI gets out of control and then says, oh, we should probably start to put in some regulations and figure out how to control this. It's, the cat's out of the bag there. But then how do you get business and people that are competing with each other to move fast to slow down and talk out the problems and implement some things that will make them move slower in order to make sure that whatever they end up building is actually done in a way that benefits society. And it looks like you're kind of taking a step also in this direction with your role in IEEE with the ethics certification program for autonomous and intelligent systems. What's the backstory there? And actually, I mean, more generally, I'd be really interested in hearing your thoughts on this general problem of how do we get industry actively involved in coming up with solutions, before the problem really, emerges and society is, screaming at them to do so.
Well, I guess like the first thing that comes to mind is sort of the analogy, and the analogy is that if you had a horse that once it took off doubled its speed every 2 steps, and you wanted to build a bridle while riding that horse and then put it on the horse, your odds are pretty slim. So you have to build the bridle first and put it on the horse before the horse takes off. You'll never catch an exponentially faster horse at at human regulatory and legal, speed, right? So so first thing is there's no slowing down, and you're not going to slow the horse down, and innovation isn't going to slow down. And as soon as the thing gets to the point where it can basically optimize itself, human scale timescales are become irrelevant. So that's not even an option. You have to do it beforehand. And now, with that being said, I'm not a fan of the sort of Skynet, Ultron, monolithic AI that figures everything out and takes over the world theory. I don't think it's a good theory. I don't think it's a realistic fear. I don't think it's. I don't even think it's very likely. And Neil Bostrom and a lot of the, even Elon and the rest have been very phobic about this. And I think there's plenty to be concerned about, given the current types of AIs that are essentially algorithms on steroids that can't understand the effects that they cause. And so you do have if you have a machine process in software that has some sort of optimization function that doesn't know what cause and effect is, then yeah, you really do have a concern. It doesn't mean that thing can just suddenly take over the world. And so these are sci-fi horror stories for a reason, because they're dramatic and sort of provocative. But I don't think that those are engineering probabilities around that. So let me just kind of frame it that way. The approach that we took, and the first thing that we recognized when we started to look at the problem, was that if you have exponential technology that converges into a network, you have exponentials, right? So if you have 100 billion IoT devices and you've got self-replicating AI, you have, we just had breakthrough in fusion. The cost of energy may begin to plummet over the next few decades. A handful of these events completely change the dynamics. When you have virtual environments that can be as hyper-realistic and immersive as anything that we experience today, when the interface becomes a brain-computer interface, and so you're not even having to deal with interfaces that would reduce that hyper-realism, there's so many ethical and value-based questions that emerge from that it boggles the mind. So one of the two things that Dan and I did in the very beginning when we started this up in 2017 was we kind of had an aha moment where we sort of cracked the code, the matrix code, if you will, about how all these things would become interoperable. The minute that we realized that they could become interoperable, then the question was, how could they be governable? Because the power structure, power rating goes through the roof. So then the question became, well, does the thing that makes them interoperable make them governable? So what I mean by that is there a way to design a network not like the internet, where everything is open? So think about this today. The internet is open, the World Wide Web is open, crypto wallets are open, your email inbox is open, and everything can just be spammed and hit by any other server at any point in time, and there's no way to stop it, right? So it's like, a million people knocking at your door. Like there's laws against people coming on your property. There's laws about people getting in your car. There's laws about people entering your house, your business, whatever. We don't have that in our computer networks. We have to add second level security and key systems and cryptography and all this other stuff because the networks were designed to be open. So what you really want is something like these zero trust architectures that are emerging now, which is like, I don't want 99% trust that nothing comes in. I want 100%. Nothing comes in without a credential that it has the right to basically access some part of the system. And every single move that it has to make has to be permissioned. So you have to reverse the entire paradigm and say that everything has to basically be approved. That means you could say, well, for all my stuff, I want it to be open, and that's fine. But it may be that we don't want drones to be able to fly within certain ranges of airports. And maybe we don't want them to be able to have cameras on when they're flying over nursery schools. Maybe that there are AIs that should have to basically prove who they are before they can access certain servers. Software systems that do the same. Holographic information that can't be presented in certain locations because it's inappropriate or it's harmful or it's dangerous or it's a threat or it's a lie or whatever. So how do you govern these things? And one of the answers is you have to basically build in security and trust as the default layer, right? And permissioning becomes a part of that. So that starts to then deal with that, at least without going into a lot of detail, a premise upon which then you could say, okay, now we can build a system where exponential things and the benefits of exponential things come from their interoperability in a network, but every interaction is basically a function of having the right to perform the activity. So then you can make them compatible with laws or with rules or with policies or any condition that you might set, right? So, you and I have young children. We have to set rules for them. Like, here, you can have a popsicle. I want another one. You can't have it. Like, and they throw a fit, right? You have to put the cookie jar up high. Like, there's things that the world does to basically mediate the actions and demands of other things, and in these systems, that has to become a prerequisite. And so then you avoid a lot of these, like I said, sci-fi dystopic outcomes where Ultron uploads itself to the internet and downloads all the information and then suddenly can like take over any number of, robots or drones or systems. Like, no, you have to ask all along the way and you don't have a certificate. So you can't even get into that system. Then you can talk about cryptography and all the rest of this stuff as like additional, key value, key signatures and the rest of this stuff. So there's a whole lot of factors, and the IoT itself is actually a huge problem space because of the way that the protocols are designed. So to tie it back to your question around the IEEE, we spent the first 2 years just designing essentially a standard, a protocol for communication, for interoperability and governance of digital systems, including and especially ones that could interact with the physical world, collecting information through the IoT or taking action through some robotics system or actuator. And that we went to the IEEE and said, here's our 80-page specification. And they said, we will help you set this up to become the global standard for the mediation of cyber physical activities for all systems on the planet. That was part one. Part two is Dan and I wrote a book called The Spatial Web, which is this idea of a network of spaces where intelligent digital activities are occurring instead of a web of pages, a web of spaces. And we described our entire vision for the world. We described what the threats and challenges we saw were. We described the failings of Web 2.0 and the architectural design shortcomings that we saw and the need for a type of new set of standards upon which we can build new infrastructure, new applications, and get the benefits of intelligent exponential technologies while being able to get the bridle on the horse before it takes off.
Okay, yeah, interesting. Well, it's good to see organizations like IEEE getting involved here at an early stage because they have a lot of credibility as kind of good actors on the regulatory stage. Yeah, this is a fishy problem, and I hope that you and everybody else who's working on this makes some significant progress. But yeah, I imagine this will be a long-term struggle to figure out how to get all the actors in the market engaged. But let's assume that we are able to kind of solve this issue and generally develop AI systems that are acting in the interest of humanity or of the people that are managing them. We're going to then have kind of another, you could call it another problem or another question at least, which is this question of when these AI systems, especially the more general intelligence AI systems, are developed, are we looking at a future where we have a handful of systems that are developed by OpenAI or Google or maybe Alibaba, or are we going to have 1,000 entrepreneurs building the kind of little AIs that are collaborating with each other in this network and maybe in an integrated way becoming something that approaches kind of an artificial general intelligence, but doing it in a much more decentralized way? Do you have a view on what is more likely or what is more preferred from a kind of a social outcome? And this might also lead a little bit to the vision for KOSM. I'm interested in seeing how that fits into this space.
Yeah, so I think a couple of thoughts. Number one is that the idea of a monolithic AI, the sort of the artificial superintelligence, which is the sort of the described end state of AI. So you get to AGI where it's human level intelligence. At that point, it can update itself. So, and then a lot of the stories are like, well, then does it take like a minute or 100 years for it to become smarter than all of human intelligence on the planet? And no one knows. And so Ray Kurzweil talks about this as the singularity, right? At 2045 or so is the prediction where, we can't see past that line, like the singularity of a black hole. We don't know what happens the next second after AGI at that level actually clicks in. Now, there's tons of debates about, is that even possible? If it's possible, what is that line? What would happen after that point? And, there's a lot of ink, well, I suppose digital ink being spilled on that topic. There was just a debate with, Noam Chomsky and Gary Marcus, and a bunch of sort of the world's, I guess, thought leaders in the AI space last month in December, called the AGI debate, which was fantastic. And they tackle a lot of these concerns and narratives, certainly talking about the shortcomings of current AI, its unlikeliness to get to AGI. And the analogy there is that, yes, we've built a very tall ladder and we're building taller ladders, and what an amazing view we can get from something like ChatGPT. But you can't just extend that ladder to the moon. You actually have to have an entirely different approach to get that far out. And so I think that, first of all, the delineation between what current AI is, which is essentially a machine process in software, which can produce intelligent like outcomes and outputs, which I find to be spectacular and amazing and very exciting, but which have very significant shortcomings. They're not explainable. They're not transparent. You can't moderate them, really. You don't really know how they've arrived at any sort of decision. They are really statistical parrots at scale. So when you put one in a Tesla and you say, we expect regulators to approve the ability for you to take a nap in the back while it drives you around, Elon pops up every 12 months, like on Groundhog Day, and says, like, full self driving is coming this year. And no, it's not. The limitations of deep learning are being felt all over the place, even as we're seeing on the opposite side some of the realizations of the power of the current approach to what I think is still considered narrow AI. When you shift to the concept of artificial general intelligence, what you're looking for, there is a distinction that we believe is important, and that distinction is that the system must be able to have a perspective. It must have a model of the world inside of it upon which it reasons, upon which it can plan, upon which it can have a set of beliefs about what might occur about its next action. This leads to things like curiosity and creativity. So you can't ask ChatGPT, like, hey, what do you think my next thought is? We've been talking about, something for an hour. It'll be like, I don't do that. I can't do that. But what you want is something that says, well, I'm curious about you. Why did you ask that question? And that's not what it's capable of doing. It can't do that. And it can't actually input the information if you give it to it, because it's not part of the training data. The problem you have with this is that when the training data, or the big data approach to AI, which is the current sort of state of the art, is that whatever's in the training data is all that the system's able to learn, right? And so if the car has learned that stop signs are on the side of roads, and it's driving down the freeway, and there's a truck moving stop signs from point A to point B on the freeway, what does the car decide to do? Stop on the freeway? Because it doesn't understand the full context. It's not a knowledge-based system. It's just an information-based system. It doesn't have the relationships. It doesn't understand the nested nature of, doesn't even know what driving is. It doesn't know what cars are. Doesn't know what a freeway is, right? It knows what lines are, and it knows what speeds are, and it knows some of these things, but it doesn't know the rest of the context. And so it hasn't achieved knowledge. And so this distinction between the power of big data, which is really what's gotten us here today, and knowledge, which is what you and I have, and even having our 2-year-olds or our 3-year-olds, we've watched them learn about, like, the concept of a cow, what a cow looks like, what a cow sounds like, what a cow eats. And they can tell a stuffed animal cow and a real picture of a cow and a cartoon version of a cow. And they map all these things together. And these systems have a real limitation around that. And so when they say, like, hey, this person should or shouldn't get credit, maybe it's because, their name is, an uncommon name. And so it's like, oh, this is an African name. This person should get credit because most of the data I have shows that, like, John Thompson. That's a good name that gets credit. So when it says, like, amputate the leg, and you go, like, well, why? And it can't tell you. Like, that's the limitations that we're dealing with today. Black boxes built on big data. They're essentially an industrial process. So when we talk about the future, will there be many AIs, or will there be little ones? What you are seeing right now is sort of foundational layers, which are coming with these sort of large language models from OpenAI and Google and others, those that have access and can afford to call big data and get sort of, let's say, in level one intelligence layer. And on top of this, you're already starting to see a bunch of applications. Someone building something like Jasper.ai for copywriting and marketing. It's absolutely fantastic. And then there's Rally that's going to be for like, you're not going to go to LegalZoom and look up contracts. You're going to say, here's the legal situation that I want a contract for, and it'll generate a contract for you, right? So it'll be hundreds and then thousands of applications that are going to use these base layer AI capabilities from big companies, much like we run on AWS today, or use Google services for something. And I think that will be very likely for a lot of the let's call it infrastructure level intelligence. And then you have all these really cool applications, which will come from 1,000,001 entrepreneurs, over the course of the next decade here. None of which will be AGI, but we'll all be smarter than every single software application we have today, and will have exponential value, and will essentially be power tools, intelligent power tools for people like working in the marketing field, or working in the medical field, or working in the fitness training field, or working in the mental health field. They'll essentially be, assistants that are helping to guide and inform and educate, and they'll be personal ones that'll be absolutely fantastic. So I think you're going to see, 10x to 100x increase in effectiveness around the interactions with digital systems because of the breakthroughs of things like ChatGPT and for designers, DALL-E and Midjourney and all this amazing stuff. And it fundamentally changes it. Like, if you need to be a skilled carpenter in order to use certain set of saws, but then you can get a skill saw and basically allow lots of people to start to be, not be carpenters, but to cut wood, then lots of people can become designers without having to have learned how to use the original tools, right? And so there's always a bias because we consider that to be a skill. Well, power tools make that so that you democratize that capability. And so, it's not about people competing with AI. You're competing with the people that are going to adopt the AI. And if you decide not to, you can saw as fast as you like, but, the guy next door who just got the skill saw is going to be able to cut more wood.
Yeah, my brother's playing around with drawing now. So he's an engineer, but he's a great artist, and he's kind of playing around with his skill set. And I have a little game now where he'll show me something, and then I go on, DALL-E 2 and kind of see, okay, can I try to replicate that within like 10 seconds, his art is still a little bit better than what DALL-E 2 is performing generally, but, or at least they can't emulate exactly what he's creating. It is a power tool that allows somebody like me who has really no artistic capability to generate things that are pretty reasonable in seconds, right? It's incredible. So we have this world where I like this concept of kind of power tools that are all narrow AI solving specific problems. And I think for a lot of people, that is a future that they would want to live in, right? Where there's a bunch of narrow eyes that are completely controlled and scoped, and we don't have to deal with this general AI mess. But of course, there's that feasibility there. Where does KOSM fit into this ecosystem?
So what Apple did in the smartphone era was they built a developer ecosystem around a platform. And so they developed iOS, which was a new way of interfacing with a computer, essentially a computer in your hand, which you didn't type, keyboard or use a mouse. You touched it. It had GPS, it had accelerometers, had all these other essentially package of IoT devices inside of it. And this enabled things like Uber and DoorDash and all these other services, and Instagram and Facebook. And, literally like that whole Web 2 era is a product of mobile and the product of the smartphone. But, when Steve Jobs came out in 2007 and said, here's the iPhone, which was like kind of an iPod with a phone that you could go online with. That was the three main capabilities. There was 12 apps, calculator, maps, email, right, and so on and so forth. The next year they came out and they said, here's the app store, 500 apps. And now there's 5 million apps. And those millions of developers that used to mainly be products that were developed by corporations or companies, that there were maybe 1,000 programs you could put on a Dell computer in 2005, right? And you probably wouldn't only put more than 30 or 40. There's millions of mobile apps, and the barrier to entry was lowered to where high school kids were able to develop apps, because they democratized the development of applications, and the smartphone became the best interface to users. So you got millions of developers that produce billions of users that produce trillions of dollars in value in a 15-year timeline, right? What's just happened, you could kind of think of like the GPT moment as the crossover just a few weeks ago, which was 1 million people started using an app faster than any app that had ever been produced or any website, traction by, 5 days. It was up with to 1 million people. That shift where you're not like, I want to go on Google, I've got a question, give me search results and I'll go try to find the right result. And you're trying to do your best job to give me the best result, trying to anticipate what I really want instead of I can just go ask a question to a chatbot and just gives me the answer. So I don't want to search and get search results. I want to ask a question and get an answer. And so everyone went online and started asking questions and getting answers and having conversations and trying to the extent, give me a fitness program, given that I want to lose this much amount of weight, but I have a gluten allergy, and give me an outline for what my workouts are each day of the week, plus recipes for food, blah, 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 under a certain budget, and blah, there you go, right? And it was just kicking this stuff out. So what's happened? The moment like when water goes, from 33 degrees to 32 degrees, it completely phase shifts into a different structure. That's what's just, I think we're seeing that moment in computing happen right now. And the next era is now going to be about AI applications, smart apps for everything, not just apps on a smartphone, but smart apps for everything, all basically driven by artificial intelligence. And so what KOSM is KOSM is essentially doing for AI what Apple did for the smartphone. We're building the world's first AI operating system, platform, and ecosystem for developers to be able to develop AI applications for anything. Because they're built on the proto version of the standards we talked about, those AI applications can be interoperable and they'll be compliant with the standards. And so we've got this whole head start because we have essentially a language that we invented that allows it to make it quite easy to design and develop the kinds of knowledge structures upon which AIs can run that doesn't require big data at all. You can basically build AIs on our system without big data. So if you want to bootstrap it with big data, great. If you've got your own personal information, like the data coming off of my Oura Ring or my Apple Watch or any other sort of data set, or I'm an enterprise, I'm a business with my own, corporate data, like that doesn't work with GPT. Like 99% of the web is behind a password. So what about like you and I have information in an iCloud, or we have information, we've got LinkedIn is not available without a password. Facebook is, the Twitter is, most of the web, 99% of the web is not available to just be digested. It's actually has terms and conditions for using that material. It's illegal to crawl it. So, and it's certainly illegal to break into an enterprise platform and take their data. So these large language models don't have access to that information. They don't know anything about that. And they can't do anything with that. Although they do have general concepts. It doesn't help if I'm an engineer who needs to change something or would like an AI to help assist me changing a part on an airplane, a particular model of an airplane for Boeing. But that information isn't available for ChatGPT. And so it's not going to be able to walk me through that process, just like it might be able to tell me what kind of food to cook for the week, right? So there's a whole universe of information that can be shared in our, what we call knowledge models. So KOSM stands for knowledge-oriented software model, using our language that takes you from like the crude oil, refining process that large language models do with raw big data to try to get to like information understanding. We're able to basically start at a higher level and say, form relationships between all these data in this very common sort of universal standardized structure that lets you then immediately be able to start to ask questions and infer outcomes and reason and plan on those data sets. So that's what KOSM is essentially doing versus is intending to do for AI what Apple did for smartphone apps. Democratize them.
Well, so I'm imagining two different ways that this could work, and let me explain how I'm thinking through this. So one is, I have my micro data set, and I'm a corporate working in managing factories, and I need a toolkit, a set of frameworks to quickly build AIs that are specific to my purpose and are ideally also leveraging broader data sets that are can support with training, et cetera. Because I don't have sufficient data maybe to solve that problem internally. And so there could be a platform to support this. And then there would be the second alternative, which would be more the probably the closer analog to the App Store, which is, okay, I'm going to use DALL-E to create an image, but then the face of the image is all screwed up. So I'm going to use a different algorithm to fix the face because that's customized for the face. And then I want to animate the image. I'm going to use a different algorithm to now animate this image. And then I want to add voiceover. I'm going to use a different algorithm to add voice. And then maybe there's some custom thing that I internally build that adds some magic to this final product. And I'm going to add my layer on top. And then you end up having 5 different AI apps that are all contributing to the final product, but they're all from different app developers. And right now, I know artists are kind of doing this, but it's like a very ad hoc process. It's like, alchemy of them. It's not an app store. It's So, are you going in both directions? Is there one area that you see more potential in?
I think there'll be quite a few platforms that emerge over the next 24 months that do the sort of chaining, like what you're talking about. And then those are going to be really cool and very popular and will have, multi-billion-dollar valuations overnight. And right now you're seeing all the sort of like little toy versions of it and people just throwing stuff up on GitHub, like essentially, just automating a copy paste process or in one form or another, and just put some buttons on so you can kind of do out painting and in painting. It's very cool. That's going to get commoditized like in the hour after one does it, there'll be 5 more, right? So that's not a really great business barrier to entry, although I think that capability will be widely adopted and very useful. And you could do that on our platform as well. And so there'll be some benefits to that. There's another piece of the puzzle, which we've sort of hinted at during the course of this conversation, which is that the first thing you can make on KOSM is going to be what we call a KOSM, essentially a knowledge model. That knowledge model can be updated and enriched. That knowledge model is not limited to text. You can put unstructured or structured data. You can put IoT data. You can put basically temperature data in there. So if you're talking about like modeling a digital twin of a factory or a warehouse or a port or your home, like you can have inputs from every one of your systems building out effectively a knowledge model with spatial information and physical data. And it all gets correlated together into a coherent knowledge structure, which is not possible for, say, something like ChatGPT, which is a text-based corpus, right? And DALL-E is doing it on a different sort of corpus. But you want that general capability to take any input and basically, like what's called sensor fusion is one example. So you and I are able to make sense of our environment right now, even though we're pulling in inputs from a bunch of different systems. Like my skin can tell what the temperature is in the room. I've got 2 eyes; they're synthesizing some inputs. I'm taking in audio from my ears, which is a completely different kind of input. One is using light, one is using literally like sound pressure, and I'm synthesizing all these into like a single world model, right, in real time. Our platform allows you to do that. And our language, the standards language that we developed, that's what it's based on. And so everyone's going to be able to do this. And that part we've already set up to basically be free. So essentially build out a monetization layer to make it easy. So what was impossible, the standards make possible. KOSM then makes it easy. The second piece of that is once you've got that knowledge model, we've been working on, and we've just released a paper last month on what we do think the future of artificial general intelligence is. And it is an ecosystem, a network of multiple different intelligent agents, hybrids even of where human intelligence and algorithmic intelligence and what's called active inference-based intelligence, which is that sort of adaptive intelligence with a model of the world that can update that model based on new information. Like I'm driving down the street, whoa, the stop signs are like in the back of that truck. I'm on the freeway. I shouldn't stop. Well, I guess you can put stop signs in the back of trucks. Okay, let me just update that. And then now you can push that through the entire system. So that prevents all kinds of accidents when you have a network structure of intelligence. So that this network of AIs with interface to the IoT and to databases and to robotic system is more or less the spatial web. What we are doing now is we recently announced the world's top computational neuroscientist who joined the company as our chief scientist, and his name is Professor Carl Friston. Carl Friston is sort of known for a thesis that is like if you take Einstein's ideas around sort of breakthrough on E equals mc squared relative to physics, Friston has done that for intelligence. And what he's done is he's basically described this idea of how actual intelligence has to model the environment, guess about what type of change needs to happen, make that change, and then see whether or not it works. So you're either trying to update the world or update your model. And if you can perform that loop, that's a genuinely intelligent system. That's the kind of thing we're building into our software, which we call KOSM agents. Those KOSM agents will operate on those KOSM models, and they'll be able to update those on an ongoing basis in real time. So the second thing that we're offering here as we go into 24 is the ability to have these agents doing that kind of updating for you. These are agents that can learn. These are agents that can adapt. These are agents that can understand and share bits of knowledge with each other across the KOSM network, which is just kind of a subnet of the spatial web, in a standardized format that is interoperable and governable, and upon which I expect the laws of nations to actually be drafted upon, because this is the only way you can translate laws of the land into something that can be machine readable and machine executable. And we've been testing this with the European Commission with AI-powered drones for the last 3 years. This is not theoretical. We've proven and borne this out already. In fact, we're the only ones doing it that I'm aware of on the planet, working with a lot of universities and legal and ethics groups out of Europe in order to test this. So we're lining up all of these components and this crossover point as a company, which we're also a publicly traded company, a small cap company that most of you have never heard of. But I expect by the end of the year, we may have garnered some new attention. So what we've done is we've laid out in our white paper more or less what we think is an 8-year path to human level intelligence and software systems. 2 years from now, we expect to be able to demonstrate what's called sentient intelligence. That's that basic level of adaptation. And then at 4 years, there's what's called sophisticated intelligence. And then you get to essentially what's like sapient level intelligence, of which we're, right now in the research lab, we're already seeing evidence of these capabilities now. So like the things that lead to that are not theoretical for us. We're actually testing and seeing some of those effects now. So take a while to scale this to product level, and we're not ready to show things until they're ready. But the opportunity for this sort of what we call ecosystems of intelligence, which are really about a shared network of intelligence where the activities of these things can be trusted, can be transparent. You can query them and they can give you answers, and you can constrain and restrict what their activities are, or even what information or knowledge they have access to, or what they can share with others. Gives you the ability to, in what we hope, build and get the benefit of these exponential technologies that we think are so cool and that from our sci-fi stories, without the kind of dystopic outcomes that come from the runaway power of these technologies.
Okay, interesting. There's a lot of different things I want to kind of riff off of here, but maybe a first one would be, how does Wayfinder fit into this? Because Wayfinder is very much a vertical software application. So it's kind of curious on your website. You have KOSM, which is this kind of horizontal general AI platform, and then you have like a vertical, which is AI assisted order picking. I'd say a very traditional problem for a warehouse to solve. Is this intended as kind of like an illustration of the application that KOSM would be building in the future?
That's right. So Wayfinder actually runs on KOSM, and which runs on a proto version of the standards today. So Wayfinder was like a vertical proof of concept. We went into an industry we knew nothing about. We basically said, okay, can AI, intelligence systems essentially improve in a physical real world environment and guide warehouse workers better than any other state of the art system? And so we did this. This is a bit like, can you put a calculator that you can touch a screen on, like Apple did when they first came out? The email calculator, nothing innovative really that Apple put on that phone. All the real innovation on the apps came from everyone else, but they built that infrastructure out first. So Wayfinder was a proof of concept that turned into a $25 million contract for us with our very first pilot customer, because we were able to demonstrate 35+% productivity gains over millions and millions and millions of times. That's then turned into a resale agreement, which we just announced 2 months ago with Blue Yonder, who's the largest warehouse management system provider in the world. 3,000 plus customers, 80 countries, like every major, store at your local mall probably runs their warehouse management system in their distribution center around the world. And they saw what we were doing and said, we want to now resell this to all of our customers. So just by showing one intelligent app in one vertical in an area we knew nothing about, we got an 8-figure contract as the first customer. And then we got the biggest platform provider in the entire planet to basically say, well, we're going to take this and go resell it to our customers. So we're able to, I think, demonstrate genuine efficacy of the capabilities technologically, but we're also to show market traction and what I consider hyper credibility, because the biggest whale in the sea basically said, cool, we don't have this. Our customers want this. Can we take this and resell this? So as we're building out the horizontal capabilities, it certainly take a bit longer. We built out our own capability on top to demonstrate that. And then that's turned into a whole business, for us that I think makes us a good bet from an investment perspective. And especially as a public company, if this is the beginning of the AI wave, the opportunity for the public to invest is almost nothing, because all of the big investments will come from venture capital and private strategic investment. Like we've seen $10 billion potentially going into OpenAI, right? And all those little vertical ones that you're talking about is going to be Kleiner Perkins and Sequoia and everyone else. And they're going to make 90% of the profits for the next 5 to 10 years before the public even gets the first bite at the apple. But Versus is a public company. And so if you even as a retail investor wanted to play the game, there's hardly anywhere to go. So we're the only, I think, pure play horizontal AI opportunity in the entire retail market. And I think that's a very interesting position to be, especially as I think the markets start to bounce back in 2023 and we start to get liftoff, through the course of the year and into 24. So I think we're really well positioned to the point where the core capabilities that we invented, we gave away as a public utility through the IEEE. We take the company public so that the public actually can be owners in the process with us and actually benefit from the growth of catching this next big technological wave. And that lines up with the kind of world that we want to live in. And so we're demonstrating our values literally by the way we're architecting our technology and our company.
Okay, yeah, interesting, and that's an incredibly successful pilot project. So congratulations on that. Many of my corporate clients would be envious. Okay, interesting. So maybe just to wrap up here, it sounds like you have good traction already with Wayfinder. Nonetheless, this is just a monumental challenge, right? And we have incredible technical challenges here because it's basically a series of breakthroughs that are required, right? This is not kind of an incremental set of improvements. There are regulatory challenges because this involves basically, you said you want governments to be kind of writing laws on the platform and embedding them into code so that they can be kind of deployed automatically. So obviously, you're going to have to deal with bureaucracy, right? And then you have the business challenges of companies protecting their own business. Companies have legacy processes, legacy systems, etc. So you have these different challenges. When you look at the challenge landscape in terms of getting this to market, what is it that you anticipate is going to be the most? What are the biggest risks among those? Or maybe there's things that I haven't mentioned there that you're more worried about. But what are the biggest risks? And then maybe if you can share about how you're addressing those, whether it's through partnerships, in order to make sure that you can overcome some of these also these human challenges.
Great question. I think that one of the most startups have a problem where they've got a product to sell, supply, and they don't have demand and they have to go generate demand. What we have is an overabundance of demand and not enough supply. There's hundreds of companies on our lead list. Most of them are multi-billion dollar, like Fortune 500s and Global 1000s that we've spoken to in the last 2 years that want to use our technology. And we haven't made it easy for them to do that yet because we're the only ones who know how to fly the plane. And hence needing to build out the capabilities this year that then will allow third parties to be able to do that. The other pilots and pipelines we have now are all like multi-billion dollar companies. The large, like you would recognize almost every logo. A lot of that came from the fact that we wrote a book in 2019 that then got picked up by CIOs and CTOs around the world who started reading it, in part because Deloitte wrote an entire article from their research team in 2020 describing the work that we're doing around the idea of the spatial web as the future of computing. And literally the title is What Business Leaders Need to Know About the Future of Computing. So this went out to all the CIOs and CTOs in Deloitte's stable, which is pretty much the Global 1000. And the proverbial phone started ringing off the hook. So like CIOs from the largest companies in the world were reaching out to us on LinkedIn. What are you guys doing over here? I've got a spaghetti mess of data and a 40-year-old, stack of technology that I can't get anything to work. And so we don't see an adoption problem. And the what we see is an embarrassment of demand. So like the EU, we didn't go to the European Commission and say, hey, we've got a great idea. Can we do a test? They've said, we're trying to find people to solve this problem because otherwise we can't have drones flying around in our cities. And so we basically just put in an offer for grants with 80 other companies around the world. And then we won it because we're the only ones so we've got an underlying language that we're building as a standard because of the IEEE that's teed up to do this. The working group members in the IEEE are from some of the largest corporations and governments in the world right now. So in almost every case, they're pulling, we're not pushing. And so I would say that this is a zeitgeist moment and opportunity. And our approach was, let's create awareness around what we're doing instead of let's create a sales pipeline. The sales pipeline just literally formed by itself. And then the kind of credibility we get and the interest that people have because we're taking a standards-based approach, particularly for large corporations and governments, means that we're not creating a lock-in scenario for them. So it's not like, hey, come buy our solution. It's the only way. And by the way, we're the new Microsoft. We're going to lock you in for 30 years. It's like, it's a standard. If at any point you want to kick us out, provided they adopt us, I guess, in the first place, there's a path for them to be able to continue to operate. And so that's a bet that they're interested in making. Now, that is not the same as pulling in a bunch of small fish, which you can show very quickly. Whales are hard to pull in. So we need the Deloittes and Accentures and others to actually act as channel partners for us and do these implementations with these large customers. The pilots we're doing right now, like even if you get 8 figures per each, maybe we could do 4 or 5 a year. That's not a scalable business for us, right? But it's worth noting that the vice chairman of Deloitte, who at the time that our article came out said that the spatial web was going to be bigger than the internet, has left and has joined our board as the chairman of our company. So the alignments that we have with respect to business, to universities, academia, government alliances, standards bodies alliances, and then the type of pipeline we have from a commercial perspective on top of the technological breakthroughs we have really does seem to be one of the, in 30 plus years of being in technology business space, I've never even seen something queue up this way. And whereas we're pretty smart guys, a lot of it is just a function of the timing. Like this is like back in the early 90s where everybody, regardless of industry, all wanted the same thing. How do we get online? Right. And so the barrier to entry is that, Peter Diamandis is one of the advisors to our company, is one of the known, sort of top futurists in the world. And he put out a tweet like a few weeks ago that said there's going to be two kinds of companies at the end of the decade. Those that embrace AI and those that don't exist anymore. And so I think that the pressure is already there. The competitive pressure is there. The need to digitally transform is there. It's really hard and it's really messy and it's really difficult. And the capabilities that we've invented and that we're commercializing are making it easy. And so that easy piece is where our business, I think, thrives. And that goes back to that Apple example. Apple made it easy, and suddenly high school kids could design, apps when you used to need, you need a bunch of PhDs or someone a bunch of engineers, senior engineers working in a corporation. Before the personal computing era, computers were the size of rooms, and you needed a team of scientists to be able to just run one computer. That's what AI is like today. You need a team of data scientists to basically build an AI with a bunch of big data and only done by big tech. We're making it so that you don't need that big data. You just need a little bit of knowledge, and our system can basically help you immediately extract and get value and reason over that knowledge, whether you're a large corporation or you're just sort of an individual developer. I think as we move into later this year, 24 and 25, that's going to become increasingly apparent. And we're hoping that our actions speak louder than our words at that point.
Yeah, fantastic. Well, it's a great vision, and I really wish you success, Gabriel. And I think that's a good thought to end on here. That there's going to be two types of companies that embrace AI and companies that no longer exist. So for those of our listeners who are interested in learning more about what you're doing and maybe exploring collaboration, what's the best way for them to reach out to Versus?
Yeah, so we are online at versus.ai or versus.io. You can just come to the website and forms will direct you to the right spot. I'm on Twitter, but I'm not very involved. Twitter's the dumpster fire, so don't go there. I hope Elon pulls it off, but it's not looking great. We're also trading on the New York Exchange in Canada under the ticker VERS, and we're trading in the US under VRSSF on the OTCQX. And more exciting news to come over the course of the year. We're really, really pumped for 2023 and really appreciate the opportunity to speak with you here today, Eric.
Thanks for tuning in to another edition of the Industrial IoT Spotlight. Don't forget to follow us on Twitter at IoT1HQ and to check out our database of case studies on IoT1.com. If you have unique insight or a project deployment story to share, we'd love to feature you on a future edition. Write us at eric.walenza@iot1.com.